let's see how we can find a maximum value from the list. So I have a list, let's say 1, 4, 8, and 3, and 6. And I would like to know what's the maximum value out of those numbers, so probably the correct answer should be 8. And how to do it? So, of course, there are several different ways how to approach this problem. But let's say we have the same problem for real-life situation. For example, we have a list of shops. There are 5 shops in some supermarket or whatever, and we would like to know in which shop there are, I don't know, let's say those are shoe shops, and where I can find the most expensive shoes for whatever reason. And how I would approach this problem. So let's say I will go to the first shop and see, okay, those shoes cost us €1, and I will write it down. The highest price up or so far is 1. Now I will go to the second shop and I see, okay, here the value is higher. I will overwrite this value here. So I will just say that, okay, instead of 1, the current maximum price I can find is 4. So taken only into account those 2 shops, the maximum price would be 4. Now I will go to this shop. So now I see, okay, the value is 8. I will overwrite this one here. So I get 8. And so on. So now I will go here. As the current price is lower than my current or my maximum price so far, I do nothing. I just ignore this 3. And the same goes with 6. So the 8 here is the maximum value, and this is what I have stored or written on the paper or whatever. So now I know that, for example, the maximum value here is 8. And let's see how to do it in the code. Let's say I first create a list of those numbers. And I will call it numbers. And now let's do basically the same thing. I will visit every element in this list and see whether the current value is better than my best value so far. I will add a variable best, and let's say it's 0. Currently, that's the thing. If I started here, I kind of didn't add any default value or the beginning value. So let's say the value is 0. And now let's visit every shop or every element for number in numbers. So I will compare the value, let's say here, with this value here. I will compare those. And depending on the result, whether I overwrite it or ignore the value of the shop. So if the current number is better than my current best, so if this value here is higher than this value here, I will overwrite the best value. I will just say the best value is number. Now the thing with conditionals is that you don't have to write else part. You often want to write it, but in this case there's nothing to write in this else part. What happens if it's not higher? So for example, in this case here, so I get 3 and I have 8. So what to do in this case? So basically nothing. And in this case there's no point to write this else part. So I'm only interested in this case where the current value is higher than my best value so far. And then I just say that now, okay, now the highest price is, or the best price is 4. In this case, the best price will become 8. Here nothing happens and here nothing happens. And now in the end I have my best value. Let's run this code. And I can get the correct value. This is okay for this kind of input. Let's say my numbers are as follows: -1, -5, and -10. What is the highest price in this scenario? Probably -1, because this is the highest value from this list. If I run the code, the answer is 0. Why it is 0? The problem is that initially I said that the best value is 0, and because I have a list -1, -5, -10, in every case or for every element, the current value is not higher than the best value. So if I'm here, I can see it as I already have a better price than this one, so I can ignore this. But the problem is that there's actually no actual value of 0 in my list, so it's not the correct answer. To kind of solve this problem, I cannot use 0 here. The best value cannot be initially 0, it has to be something else. One way would be to use the first value from the list. So whatever I take, the best is always the first value of the list. In current case, it's already the best value it is the highest value, so it's maybe not best example, but I can write it like that. So what I can do is that my initial value for best is the first value of the list. Let's write -11 here, for example. So in this case, it would be -11, and now I should be able to find the best value, -5, out of this list. Yeah, and that's what happens. You kind of maybe to optimize a bit the code. The problem is if I take the first value as my best value, there is no point to start looking from the first element. So maybe in this case we should start from the second element and so on, but that's not a huge issue in this example. I will just double check the first value, it doesn't affect my result because the best value is the value of the first element. Comparing first element with itself, it doesn't give us anything. So it's basically a pointless step. But to overcome this step, it's several lines of additional code maybe, or in this scenario it doesn't affect the code so much. So it's just one additional step, not like millions of additional steps. Okay. What we should also know is that in Python you have built-in function called max. So I could actually do something like that: print max and numbers. So I don't even have to have my own loop for that. There is a built-in function for that. The problem arises when the numbers list is empty. Now the question is, if the list is empty, what is the maximum value of this list? There is no concrete answer. Probably there is no such value, because if there are no values, there cannot be maximum value. So in this case, what happens is, whether I use my own code or whether I use this max, I don't get an answer. If I would use only max, let's move it up here, and if I run the code, I will just add exit here, so the code doesn't run any further. What happens is that I get an error, and it says that max arg is an empty sequence. So basically you cannot take maximum value out of an empty list. The same would happen, or basically not the same. Yeah, in our case, if I take the best value from the list, or I take the first value of the list to be my best value, I would also get an error. The problem is that there is no such value as 0. I would get an error. If I did something like that, I will add 0 here. I will comment this out. I get an answer 0, but this is not correct. I mean, currently I get whatever value I put here as the best value, I get it as an answer. The problem is that because there are no numbers, the loop doesn't execute and I just get the best value I initialized here. In those cases, it's probably wise to check whether there are values. If there are no values, then you can give an error or print out that there are no values, you cannot take maximum and so on. And it's wise to say that the same applies with or when we want to find the minimum number. So in my code, I would just need to reverse this comparison here. So instead of checking whether number is bigger than or larger than the best, I just check whether it's smaller than the current best value. Or I can use built-in function min here. So to get minimum or maximum values from a list, we can use built-in functions. So in this case, the best is actually not 0. It was 0 because I initialized this best as 0. Now I can numbers minus or not numbers 0. Currently my own code finds a maximum value, but here with max I get this -5 as maximum value, and with this code here I get this -11, which is the minimum value from this list. So when you want to find minimum or maximum numbers from the list, it's wise to use built-in functions like min and max. There are certain cases where you maybe want to write your own code. For example, let's say that we, in addition to find the value, we would like to know the shop. So we would like to know that the best value is inside this shop. With min and max, it's not so easy. I mean, you just get the number. Now you probably should do a second loop where you get every element and see whether it's 8, and then you can see the index here. Instead, we can do it in one loop. So to get both the value and the index, we can use for a loop with enumerate. For e and number in enumerate numbers. And now let's also keep the best here. Best is numbers at 0. And if the current value is, for example, bigger than best, we of course have to overwrite the best value. But instead, or in addition, we best index is, for example, -1. -1 indicates that there is no value. There is no elements or there's nothing, because indices usually are not negative numbers. So the first index is 0, 1, and so on. Although in Python you can use -1 to point to the last element, but in this case -1 means that there is no best element. And now if we have found the bigger number, for example, the case here, I overwrite the value of best. In addition, I store this index here. So I just say that the best index so far is I. And now in the end I can print out the best index and the best value itself. And now I can see that the best value, -5, is at position 1. Okay, that's a different number, so I would just comment this out. So in this case, I find 2 and 8. So the 2 is the index and the 8 is the value at this position. So in this case, it's maybe more convenient to actually have the loop inside where you can find both the value and the index for the best element. Otherwise, yeah, you can use max to find the element value, and now you should do a second loop where you basically find, yeah, now we have this maximum value and then we know the index. The problem is that max or min itself is also a loop. So then in this case you would basically do 2 loops. So you have to get over the list 2 times. So if there are like millions of elements, it can be a lot of time. So in this case it's more convenient or better to kind of use 1 loop to find the element and position in 1 run. So and yeah, the main point you take from this is that if you want to have only the value, use min or max. If you want to use both or get both the position and the value or only position, then you probably have to write your own loop.